Today we are going to talk about parallel and perpendicular lines. This is section 5 in chapter 6, so section 6.5 in your book. Before we talk about parallel and perpendicular lines, let's just review a little bit about linear equations. Okay, so in linear equations we have the standard form, which was ax plus by plus c, where that a and that b and that c, those are all numbers, right? And then we have the slope-intercept form. Remember, this is our very best friend. That's the y equals mx plus b, where m is your slope and b is your slope-intercept. Now we're going to learn a new form of a linear equation called the point-slope form. The point-slope form looks like this. Y minus y1 equals m times x minus x1. So this y and this x, the ones that don't have subscripts on them, those are just for your equation. So this is like the y and the x in this one. Those don't change. This y1 and this x1 and this m, those are things that do change. Those are the things that are given to us so that we can figure out the equation. Okay, so how do we use the point-slope form of a line? Well, let's talk about it. The point-slope form provides an alternate method of determining the equation of a line given the slope and the point. Remember, when we were previously given the slope and the point, we had to use the slope-intercept form and solve for b and then rewrite the equation. So instead of having to do all those steps, we can use the point-slope form, and it saves us a little bit of time. Okay, so let's look at an example. The equation of the line passing through -5, 2 and 3, -4. Well, the first thing we need to find is our m, right? So we're going to find the slope, we're going to use the equation y2 minus y1 over x2 minus x1. So we have -4, which is our y2, minus 2, which is our y1, all over 3, which is our x2, minus -5, which is our x1. So -4 minus 2 is -6, and 3 minus -5 is 8. And then that reduces to -3/4. So now we have our m. And now that we have an m and we have a point, we can use our slope form. The y minus y1 equals m times x minus x1. So the -3/4, our m, is going to go in for m, okay? And then we're going to choose the point 3, -4 to be our x1 and our y1. So we're going to substitute those. So we have y minus -4 equals -3/4 times x minus 3. So notice we still have a y and we still have an x. So all we have to do is clean this up a little bit and we will have our equation of a line. So y minus -4 is y plus 4. We're going to distribute this -3/4 x, or sorry, this -3/4, so we get -3/4 x, and then -3/4 times -3 becomes positive 9/4. Okay, we are almost done. The only thing we have to do now is take care of the 4. So we're going to subtract 4 from both sides, and 9/4 minus 4 gives us -7/4. And now we have our equation, y equals -3/4 x minus 7/4. So if you notice, this right here was all we had to do, which is a lot less work than what we had to do in the previous section. So you've just been taught the easiest and fastest way to do that. Oh, sorry. So final answer, 3x plus 4y equals -7 for our standard form. All right, let's look over some definitions. The definition of a parallel lines, those are lines that are in the same plane, but those lines have no points in common. They never intersect. And the definition for perpendicular lines, those are lines that meet at right angles. And remember, right angles are 90 degrees in measurement. All right, so let's talk about parallel lines. Parallel lines, we said that they have no points in common, okay? And if we're talking about linear equations are parallel if they have the same slope but different y-intercepts. So the m will be the same. the y-intercepts will be different, because if the y-intercepts were also the same, that means that they would be the same line. So we want two different lines, so the y-intercepts will be different, but we want them to have the same slope, the same m. Okay? So let's look at an example. We have these two equations, and we want to know, are they parallel or are they not parallel? So the first thing we have to do is we have to put them into y-intercept form. So for the first equation, we're going to subtract 3x from both sides and then multiply everything by -1, and we get y equals 3x minus 6. On the second equation, to solve for y, we're going to add 9x to both sides and then divide everything by 3. So we get y equals 3x plus 4, okay, which means that the slope in the first equation is 3, and the slope in the second equation is 3, and the y-intercept in the first equation is 0, -6, and the y-intercept in the second equation is 0, 4. So since they have the same slope but different y-intercepts, that means the lines are parallel. All right, let's do another example. Oh, let's see. It says find the slope of 4x plus 3y equals 17. So the first thing we want to do is we subtract 4x from both sides, and then we divide everything by 3. So our slope is -4/3. So the parallel line has the same slope and goes to the point -5, 9. So we're going to use our our point slope, which is y minus y1 equals m times x minus x1. So we know that our m is -4/3, and they said to use the point -5, 9. So we're going to let -5 be our x1 and 9 be our y1. So now all we have to do is clean this up, and we will get the equation of the line that's parallel to the original equation that we had that had the slope of -4/3. Okay, so we're going to distribute the -4/3, and then we're going to add 9 to both sides, and we get y equals -4/3 x plus 7/3. So if you notice, the slope is the same, the -4/3, but the y-intercept is different. All right, so more about slopes. Parallel lines have the same slope, which we talked about. Now let's talk about perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. So negative means opposite. So if one slope is positive, then the other one's going to be negative. If the first slope is negative, the other slope will be positive. They're opposites of each other. And reciprocal means the flip of the number. So 1/2 will become 2/1, 7 will become 1/7. The numbers will just flip. So let's look at an example. Okay, so we start with a number. We start with 8/5. The negative reciprocal will be -5/8. So again, you're going to be opposites. Since 8/5 was positive, that means your negative reciprocal is going to be negative. And then 8/5 is going to flip to get your reciprocal, and you'll get 5/8. Let's do another number, the number 9. So the number 9 is positive, which means the negative reciprocal will be negative, and then 9 will flip and become 1/9. Okay, so -13/7 is negative, so the negative reciprocal will be positive, and 13/7 is going to flip and become 7/13. All right, so now we just have A. A is any number, okay? So then you're going to put a negative in front of A, and A is going to flip and become 1/A. All right, the slope of y equals -4x plus 9 is -4, okay? That's the slope of your original equation. So if you want a line that's perpendicular to y equals -4x plus 9, you need to take the slope, take the negative of it, and take the reciprocal of it. So the negative reciprocal of -4 is going to become positive 1/4. So now you have your new slope. So now we need to know the perpendicular line that has the slope of 1/4, which is the negative reciprocal, and goes to the point 2, 7. So point slope, we're going to use the point slope, which was the y minus. All right, here we go. Here's a new example. Okay, so this one, we have two equations, 2x plus 5y equals 9 and 4x plus y equals 1. Okay, so you put both of those into y-intercept forms. The first one was y equals negative 2/5 x plus 9/5, which means that the slope was negative 2/5. The second equation, when you put it into slope-intercept form, is y equals negative 4x plus 1, which means the slope is negative 4 for the second one. So notice the first slope and the second slope, they're not the same, which means they're not parallel. And also, they're not negative reciprocals of each other, which means that they're not perpendicular either. So we know that they are going to cross each other, but it's not going to be at 90 degrees. Okay, so your turn, you're going to do 6.5, 2 through 6 evens. It's going to be due in class with your notes.